Hi, this is Steve with the Triangle 5-1 Ranch. I've spoken of Nina in some of my previous videos. Some of you may be familiar with her story, but I'll go over it just to bring new viewers up to speed. She is a 12-year-old mare that is pony sized at 13.3 hands. We got Nina from a horse rescue. She had a number of undesirable habits on the ground and under saddle. It fell on me to start teaching her better habits to get her on the payroll. I'm close to being an average-sized adult male. Nina is a very small horse, so the question comes up whether I'm too heavy for Nina to carry. In this video, I explore this question. I found two different formulas on how to calculate the weight of a horse. One formula is from Texas A&M and the other is found at horsehealthproducts.com. I'll link to both in the description section of this video. The reason I'm going to discuss finding the weight of a horse is because the weight carrying capacity is expressed as a percentage of body weight. The fact that they're two very similar formulas confused me for a while. My excuse is this: in the last 20 or so years, I've gotten into the habit of skimming things and not really reading them. Reading's a great skill that I should practice more often. I'll explain the difference between them later. The question was, how much weight can a horse carry? We will quickly think about this concept so that we can answer with a reasonable number. If you have ever participated in any task that requires you to carry weight, you understand that this is a rather nebulous concept. I can pick up and carry for a few steps my own body weight. For a short distance, I can carry a significant percentage of my body weight. For a long distance, the amount of weight I can carry is greatly reduced. When I was in the service, we'd carry close to 33% of our body weight for a large part of the day. This is also true of a horse. For this discussion, we're going to define the weight carrying capacity as what a horse can carry for a distance greater than a few steps. I'll link to a number of studies that talk about this and how they arrived at the body weight percentage they did. To keep it brief, they were looking at how much weight a horse could carry without becoming sore. I'll also speculate on how they came up with the formula. Remember, this is only speculation and not a hard guess. It is rather technical and requires a bit of algebra. If you're watching my videos, then you're probably pretty smart, so this should be no problem for you. Let's get started. I'm displaying the first of three graphics that show the formula for calculating the weight of a horse. The first is the formula that I got from Texas A&M. Weight of an adult horse using imperial units. G squared times L over 330 equals A, where G is the heart girth measured from the highest point of the withers, L is the length of the horse's body from the point of the shoulder to the point of the buttock, and A is the weight of an adult horse in pounds. I prefer this formula because it's not so ambiguous about where to make the measurement. This is the second graphic showing the next formula for calculating the weight of a horse. Weight of an adult horse using imperial units. G squared times L over 300 equals A, where G is the circumference of the barrel just behind the withers. L is the length of the horse's body from the point of the shoulder to the point of the buttock, and A is the weight of an adult horse in pounds. I say this is ambiguous because they don't quite define what behind the withers means. In the diagrams, it still shows measuring from the withers, only just behind the highest point. This is the third graphic showing the formula for calculating the weight of a horse. Weight of an adult horse using formula for metric units. G squared times L over 11,880 equals A, where G is the heart girth measured from the highest point of the withers. L is the length of the horse's body from the point of the shoulder to the point of the buttock, and A is the weight of an adult horse in kilograms. This formula is the same as the one from Texas A&M, except for the fact it is using metric measurements. The measurement for the heart girth is taken exactly the same as the first formula. For those who don't know, pounds are a unit of force, while kilograms are a unit of mass. On the planet Earth, the force of mass and mass are the same. So, we measure around the girth of the horse and then the length of the horse. We put these figures in the formulas, and we should have a pretty good idea of the weight of the horse. But I'm not going to let it go that easily. Looking at these formulas, they started looking a little familiar. I realized that these looked like the formula for figuring the volume of a cylinder. Let's explore that idea a few minutes. Looking at the next graphic, we see the formula for the volume of a cylinder. The volume of a cylinder is calculated using the equation V equals pi r squared h, where V is the volume, r is the radius of the cylinder, and h is the height. That really doesn't look the same, does it? Let's see if we can fix that. The formula for the circumference of a circle is circumference of a circle is calculated using the equation C equals 2 pi r, where C is the circumference, r is the radius. That doesn't look like anything either, but let's take the circumference and solve for r as shown in this graphic. Solving for r in the second equation, divide both sides by 2 pi. C over 2 pi equals 2 pi r over 2 pi. 2 pi cancels out on the right side of the equation, leaving C over 2 pi equals r. In this graphic, we have the value of r expressed as the ratio of the circumference in 2 pi. We substitute this back into the volume equation for r. We get V equals pi, paren, C over 2 pi, close paren, squared, h, which expands out to V equals pi, paren, C times C over 2 times 2 times pi, close paren, h. Pi cancels out on the right side of the equation, leaving V equals C times h over 2 times pi, which can be expressed. With that, we can go to the next graphic and look there. That almost looks like how we're calculating the formula for the weight of the horse. V equals C squared times h over 4 pi. I'm just going to read the next few slides to you as we go through them. G inches times G inches equals G square inches. If G is expressed in inches, then the result units would be square inches. G inches squared times L inches equals V inches cubed. If G and L are in inches, then the result or product V for volume units would be in cubic inches. Density is the ratio of mass of a unit volume. D equals M over V, where D is the density, M is the mass, and V is the volume. If we take our equation for the cylinder and substitute A, meaning the weight of an adult horse, for the V of volume, then substitute G for the heart girth of the horse, for the C of the circumference of the cylinder, and H for the height of the cylinder, for L the length of the horse, our equation looks like this. A equals G squared times L over 4 pi. The only discrepancy is that in their equation they are dividing by 330 and the value of 4 pi is closer to 12.56. To get there, they multiply the 4 pi by the calculated density of the horse. This density factor must include the weight of the rest of the body and legs and is approximately 1 pound per 26.26 cubic inches. So if we multiply g squared times L over 4 pi times 1 over 26.26, we get g squared times L over 330. Our formula for a horse's weight could be written with the units as A pounds equals G inches squared times L inches times 1 pound over 330 inches cubed, or A in pounds equals V in cubic inches over 1 times 1 pound over 330 cubic inches. The cubic inches cancel each other out, leaving the final unit in pounds. Let's go over the density factor for the metric calculation compared to the imperial. Because we're dealing with different units, is the density factor for the metric the same as the density factor for the imperial? We can show they're the same using the next two slides. To get the density factor for the metric calculation, we need to divide 11,880 by 4 pi. Factor equals 11,880 divided by 4 pi. That equals 1 kilogram per 945.38 cubic centimeters. Convert to imperial. 1 kilogram over 945.38 cubic centimeters equals 2.2 pounds divided by 57.69 cubic inches. Divide the top and bottom by 2.2. Dividing the factor by 2.20 over 2.20 is the same as dividing by 1. And any number divided by 1 gives you the same number. So 2.2 pounds divided by 57.69 cubic inches divided by 2.20 over 2.20 equals 1 pound per 26.22 cubic inches. This doesn't match exactly because of round-off errors in our calculations. So the real magic in all of this is the density factor. You can probably see where that is going to be affected by the horse's build and breed. So the final weight is just an educated estimate. Let's move on to Nina. This graphic shows a line drawing of a horse showing at what places to stop and start measurements. I measured from the point of Nina's shoulder to the point of the butt as shown in the drawing. Then I measured around the heart girth, including the highest point of Nina's wither. Let's move on to the clip of Nina being measured. In this clip, I'm attempting to demonstrate how to actually measure the horse. I could not think of a practical method of measuring the horse without assistance. My daughter Jess is shown holding the horse in the end of the tape. It is easier to get an accurate measurement if you start by placing the 1-inch mark rather than the end of the tape on the point of the shoulder, then subtracting 1 inch from the final measurement. As you can see, I came up with 60.5 inches from point of shoulder to point of butt. The tape I'm using is imperial on one side and metric on the other, so we turned it over and measured again. In metric units, as you can again see, we came up with 154 centimeters from point of shoulder to point of butt. First, we're going to measure Nina. First, we're going to measure Nina around the heart girth at the lower part of her withers. This is what I think they meant by behind the withers. So pulling it somewhat taut, I measure that at 66 inches. If I go to the highest points of her withers, I measure it at 68.5 inches. I don't know if you can see that or not. Okay, now I'm going to turn the tape over and measure it in centimeters. Okay, there I measured at 167.5 centimeters. And at the upper part, 171 centimeters. So here are the results of my measurements. Sorry that I blocked the camera view of things. The first two measurements listed are from behind the withers. The second two are from the highest point of the withers. I converted the imperial to metric and the metric to imperial so that we can tell if they agree with each other. You'll note that the measurements for the highest point of the withers are off by about an inch. I went back off camera and made the measurement again, and the metric seemed to be the most accurate, so I'll run with those numbers. I don't know why the imperial was so different. Maybe the tape was twisted on the other side of Nina. I'll start with the formula from Texas A&M, plug the numbers in, and see what her weight comes out to be. So using the imperial formula, her weight is 130 pounds. Using the metric, her weight comes out to be 379.05 kilograms, which when converted to imperial is 835 pounds. This is about 0.6% difference, which in my opinion is acceptable for what we're trying to figure out. Using the other formula, which didn't have a metric equivalent, I came out with 878 pounds. If we use the 830 pounds we previously calculated, that is about a 5.4% difference. For our purposes, I'm going to use the Texas A&M calculation for two reasons. With the other formula, I'm not sure I'm measuring from the correct place, so that could be throwing me off. The second reason is for the sake of what I'm trying to do, this is worst case, and when calculating stress, worst case is the figure you should work with. Off camera, I used my bathroom scale and weighed myself while wearing my typical riding clothes and holding the saddle, saddle pad, and bridle. This came out to be 195 pounds, which when using the 830 pound figure for Nina's weight comes out to be 23.5% of her body weight. Now comes the hard part. Is this too much weight for me to be riding Nina? The rule of thumb I found in a number of different places was that the maximum weight of rider plus tack was 20% of the horse's body weight. For more information on this, see the link in the description, Guidelines for Weight Carrying Capacity of Horses from the University of Minnesota Extension. I also looked at the now often cited 2008 study, Evaluation of Indicators of Weight Carrying Ability of Light Riding Horses from the journal Equine Veterinary Science, which is also linked in the description. I could only find the abstract and not the whole study. This is the study that the advocates for no more than 20% will point you to. Since I couldn't find the whole study, I couldn't evaluate it that well. I did find a layman's criticism of the study, which seemed quite reasonable to me. It is linked in the description and is titled The 20% Rule and an Often Cited Study. Here is even another study, which in the abstract they concluded that the maximum carrying weight for a horse was somewhere between 15 and 23% of the horse's weight in low-intensity exercise. The title of this study is Increased Rider Weight Did Not Induce Changes in Behavior and Physiological Parameters in Horses, and is linked in the description. The final study I looked at was the influence of rider-horse body weight ratio and rider-horse saddle fit on equine gait and behavior, a pilot study, also linked in the description. I had my own criticism for this study, but I won't get into it. I was somewhat skeptical of the results, not because of the methods, but because of the riders. Finally, I found 2 more articles that discuss whether to break the 20% rule or not, and if so, when. Here are the title of these articles, and they are also linked in the description. How much weight can your horse safely carry, and educate yourself beyond the 20% rule. If you have followed me this far, then you know I put a lot of study and thought into this issue. At slightly over 23% of Nina's body weight, should I be riding her? If you've ever tackled a major product, you know there is rarely an ideal situation. The world is not ideal, and so you must make some compromises. I think of these compromises as trade-offs. You trade this benefit for less than ideal feature on this segment. The goal with Nina is to make a horse that is usable over her entire natural life so that she has a job that makes her feel fulfilled and is beneficial to her caretakers. My wife, who will be the primary rider of this horse, comes in well below the 20% cutoff level. My time on Nina is to teach her new desirable habits so that she does not feel she needs to resort to her old undesirable habits. While I will be initiating this experience for Nina, my wife will go on to do a lot of the work herself, in which case I'll be riding her intermittently. The 20% rule is at most just a rule of thumb, not hard and fast, as long as it is not exceeded well beyond the capability of the horse. For the perceived benefit to Nina for the price of a heavier load, I would conclude it is worth the trade-off. If you find this video helpful, please like and subscribe and click the notification bell. Leave a comment if you want to add something or have a question or a correction. If you know someone who you think would find this video helpful, please share it with them. Thank you for watching.